NASA's Perseverance and Curiosity rovers have made groundbreaking strides in unraveling the mysteries of Mars, offering a wealth of new data and stunning imagery that continue to transform our understanding of the Red Planet. These rovers, which have been exploring Mars for years, recently transmitted images that are nothing short of breathtaking. The images showcase awe-inspiring Martian landscapes, intriguing geological formations, and potential evidence of ancient water activity that could provide clues to the planet's past, its climate, and its potential to have supported microbial life. Every photograph captured by these rovers is more than just a work of art, it's a piece of a much larger puzzle. Each image unveils a new chapter of Mars's history, revealing landscapes shaped by forces such as wind erosion, as well as possible ancient river flows and lake beds. Perseverance, which landed in Jezero Crater in February 2021, is exploring an area that scientists believe once housed a vast lake and a river delta billions of years ago. This ancient water-rich environment has long been a point of interest for researchers seeking to understand the conditions that may have once supported life on Mars. The Jezero Crater landing site was carefully chosen by scientists because of its potential to harbor preserved biosignatures, traces of past life, if Mars once hosted life. Recent images from Perseverance have shown the rover's stunning discoveries, from layered rock formations to intricate mineral deposits, all of which hold vital information. The rover's Mastcam-Z, a high-resolution imaging system, has captured detailed panoramas of the crater floor, showcasing eroded cliffs, scattered boulders, and rock formations that could have been transported by ancient river currents. These photographs, combined with data on the mineral composition of the area, have led to remarkable findings, clay and carbonate deposits that are typically found in water-rich environments. The presence of these minerals strengthens the hypothesis that Jezero Crater once hosted a long-standing body of water, raising the exciting possibility that microbial life could have flourished there in the distant past. Meanwhile, Curiosity, which has been exploring Jezero Crater since 2012, has also contributed new and valuable perspectives on the planet's diverse landscapes. One of its most significant recent discoveries came from a 360-degree panoramic view captured from the slopes of Mount Sharp, the towering central peak within Jezero Crater. This breathtaking mosaic, composed of dozens of high-resolution images, reveals a vast and varied Martian terrain. From rocky ridges and wind-swept dunes to distant hills fading into the hazy Martian horizon, the imagery paints a picture of a world with a complex geological history. Some of these photographs show distinct layering within rock formations, evidence that sediment was deposited over millions of years, possibly by ancient lakes or streams. These rock layers provide essential clues about the planet's environmental evolution, helping scientists understand how Mars transitioned from a warm, wet world to the cold, arid landscape it is today. One of the most striking findings from Curiosity involves the detection of sulfate-rich rocks in Jezero Crater. These sulfate minerals are important because they suggest that water once flowed through this region. But they also indicate that the environment may have undergone a dramatic shift, from a wetter, more hospitable climate to the dry, inhospitable conditions we see today. Scientists believe that as Mars lost its atmosphere and its water evaporated, these sulfate deposits were left behind, preserving a record of the planet's climate transformation. In addition to its geological discoveries, Curiosity has also been instrumental in studying the Martian climate. The rover's latest images show the weathering processes that have shaped the landscape over time, including wind erosion that has smoothed the surfaces of rocks and sculpted sharp ridges. These formations have been exposed to Martian dust storms for centuries, offering clues about how the thin atmosphere interacts with the surface. Curiosity has also captured images of Martian dust devils, miniature tornadoes of swirling dust, that provide further insights into the planet's atmospheric conditions. These dust devils, in particular, offer clues about Mars's wind patterns and how they have contributed to shaping the landscape over time. The rover's contributions extend beyond just capturing images of the surface. Perseverance has also been studying the Martian atmosphere and its weather patterns by recording sounds from the planet. The microphones aboard the rover have captured the eerie sound of Martian winds, the crunch of Perseverance's wheels rolling over the rocky surface, and even the hum of its scientific instruments. These sound recordings, when paired with the stunning visuals, give scientists and the public an immersive experience that brings Mars to life in ways that images alone cannot. Curiosity's more recent images have also included close-up photographs of unusual rock formations that some researchers have speculated might resemble fossilized structures. While scientists remain cautious about jumping to conclusions regarding biological significance, these images have spurred further investigations. If these rock formations were shaped by biological processes, it could offer tantalizing evidence of past life on Mars, further driving the quest for biosignatures. Meanwhile, Perseverance continues to collect rock and soil samples from Mars for a future return mission, meticulously storing them in sealed tubes. These images reveal the precise locations of sample sites, allowing scientists to determine which samples are most valuable for returning to Earth for analysis. One particular image of a rock with unique textures and color variations has raised eyebrows, as it may be a sign of past water interactions. In some of these rocks, Perseverance's SuperCam, an advanced instrument capable of analyzing rock compositions from a distance, has detected carbon-bearing materials, yet another piece of evidence pointing to the possibility that Jezero Crater could have once been a habitable environment. As Perseverance and Curiosity continue to send back their invaluable data, the images they transmit offer not just a view of Mars's surface but also vital information that will shape the course of future missions to the Red Planet. These discoveries are influencing mission planning, from the selection of landing sites to the design of future technologies for human exploration. One of the most important upcoming missions is the Mars Sample Return Mission, a collaborative effort between NASA and the European Space Agency, ESA. Perseverance's meticulous collection of samples, now stored for future retrieval, will play a key role in answering the critical question of whether life ever existed on Mars. Future human missions are also being shaped by these discoveries. The images sent back by Perseverance and Curiosity have provided new insights into the challenges astronauts will face on Mars, including the dangers of dust storms, temperature fluctuations, and wind erosion. These images have helped engineers and mission planners design better equipment and habitats for astronauts, ensuring that they are prepared to survive and thrive in the harsh Martian environment. Additionally, Perseverance's success with the Ingenuity helicopter, which has demonstrated the viability of aerial exploration on Mars, has already opened up new possibilities for future missions. Future aerial drones, larger and more advanced than Ingenuity, will likely play a role in scouting difficult-to-reach locations, providing invaluable data, and opening new scientific frontiers. These discoveries also influence the potential for utilizing in situ resources on Mars. Evidence of water-related minerals, along with signs of ice deposits beneath the surface, has led to an increased interest in extracting and utilizing local resources to support future missions. NASA's MOXIE experiment, which successfully extracted oxygen from Mars's carbon dioxide-rich atmosphere, has shown that it's possible to produce vital resources on Mars itself. If water can be extracted from the Martian soil, it would not only provide drinking water for astronauts but could also serve as a key resource for fuel production, making long-term human habitation of Mars a more feasible goal. These exciting findings are just the beginning. As Perseverance and Curiosity continue to explore Mars, they are not just answering questions but raising new ones, pushing the boundaries of human knowledge and exploration. With each new image and each new discovery, scientists come closer to answering the fundamental question of whether Mars was ever home to life. The data being collected now will influence not just future exploration but also the very way we understand the evolution of planets, life, and the potential for life beyond Earth. With collaboration between NASA, ESA, and private companies like SpaceX, the future of Mars exploration is brighter than ever. The discoveries of Perseverance and Curiosity have opened up new frontiers, and the lessons learned from these rovers will shape humanity's future endeavors on the Red Planet. The world is watching, and the potential for life on Mars is within